Last chapter, we looked at the idea of linear regression, putting data into your calculator and letting your calculator find a line of best fit that best represents the data that you put in. Okay, regression doesn't have to be just linear. It can be any type of regression that the calculator does, which is quite a few. I believe there's about 10. Okay. Just a reminder of how we do that. The first thing we do is go to Stat. And then we choose option 1, which is Edit. And we enter our data. Then we go back to Stat. And this time we have to hit the arrow over to get to the Calculate menu. And this time some of the problems we're going to look at are not going to be linear regression. We need to choose the best regression that we think it should be. Choose the type of regression. Okay, maybe we'll choose a quadratic regression or an exponential or whatever it might be. At this point, we're focusing on linear and quadratic, so that's kind of going to fit into what we're doing. Okay, there's one other piece that's there, and it might not be set up on your calculator, so we will do that in just a moment to make sure all our calculators have what we need. But there's this correlation coefficient called R. Okay, what it does is it tells how accurate the equation we get, the regression equation, is. Okay, we're asking the calculator to give us an equation of some certain form, and it'll give an equation for any form, but sometimes a line might be better than a parabola. Other times a parabola might be better than a line. So this R gives a testing or a numerical value of how accurate or how good your representation or equation that you get represents your data. If R is greater than 1, if it's greater than 0, okay, first of all, R is always between -1 and 1. Okay, if R is greater than 0 in a linear function, it tells us we have a positive linear correlation. Remember, way back in Chapter P, we talked about positive correlation and negative correlation. Well, this R gives us a little bit of information about that. Okay, we have, if R is less than 0 then, we have a negative linear correlation, meaning it's a line that's going down. Okay. Ignoring the signs, the closer to 1, the better. Okay, if it's approximately 1, if it's close to 1, then we have a strong linear correlation, meaning the points are really close to forming a line. Okay, if it's closer to 0, then there is little or no correlation. Okay, it's not really forming a line. It can give you a line, an equation for a line that fits it as best as possible, but it's telling you that really this line isn't very helpful for you. This equation isn't giving you much information about your problem. Okay, so let's walk through actually going through this whole process. And so here we're given a table of values to actually work through and find, in this case, a linear regression, and then to look at the correlation coefficient. So here we go. We're going to first do all those steps. We're going to first start by going to Stat and Edit, and we're going to enter in our data. Now, I have old data here, so I need to clear it out. The fastest way to clear it out is if you choose the heading. Don't hit delete. Be really careful about that. Delete will delete it. If you ever do that, you just need to type the L1 back in, or L2, which is second 1 and second 2. Okay, better is what we want to do is hit the clear button, and that clears out all of it, and we hit enter. That's the fast way to do it. Okay, and L2, we can hit clear and enter. And now we can start over. I could have just typed over it since the data I'm putting in is a decent amount of data. Okay, but we want our X values in L1, so we're going to put in our 0 through 8. Okay, that's our L1, that's our X values. And then we go over to L2, and we put in the values that go with it. 0 goes with 57. Okay, 1 goes with 76, and so on. Okay, I'm going to skim that over and make sure everything was typed in well. I don't want to have my data entered in inaccurately, otherwise I do not get the right equation. Okay, looks good. All right, so here's my data entered into the calculator. Then the next step says go back to stat, okay? And we choose edit, or not edit, we arrow over to calculate, and we want a linear regression, so we choose option 4. Oops, there was something else there, so let me clear that out and do that again. Stat, calculate, linear regression. Okay, this is probably what most of you see. Some of you may already see some R's here. So if you already see an R here, then you're done. Don't worry about doing this next step. Most of us don't. So what we actually need to do is tell the calculator that we want this correlation coefficient. It's called diagnostics. So if we go to the catalog, remember catalog's where you can get to everything that you can't find the menu for. So I go second catalog. Okay, it brings me here. I want to get down to the D's. So if it's already got alpha selected. If I press the key that has a D right here, x to the negative 1, it gets me down to the D's. And I need to scroll down to diagnostics on, not off, I want on. I choose that, hit enter. That now tells the calculator, I want you to actually analyze the linear regression, turn on the diagnostics. So when I go back, and I will go back to stat and calculate and do my linear regression this time, here I'm given an R squared and an R value. Okay, linear regression has the R. Everything else will just have an R squared. And the basic concept of the closer to 1, the better is true of all of our functions. The R, though, with linear functions gives us that idea of positive versus negative correlation. This is positive, so the data that we're looking at has a positive correlation. It means all the points are going up, which we can see that. They're getting larger and larger. And the R value is really close to 1. It's 9.6 or 0.969. Okay, so let's get all this information down. It says first find the equation. So the equation has a slope of 114.4, so y equals 114.4 x. And then our y-intercept, I tend to stick with 3 decimal places. I find that's a pretty good accurate value. And then we want to give our correlation coefficient, our R. And so that's 0.969. So that's telling me this line is a great estimate for this data. So this would be a good predictor of future values. And it's showing that it's going up, it's positive, it's not negative. And so then it says if the pattern continues, how many of the students will be enrolled in 2005 in this youth service program? All right, so one of the things we didn't really look closely at is what this data actually gives. It's giving data from 1990 to 1998. And we're saying x equals 0 represents 1990. So they are converted the times to their appropriate values. And so we want 2005. And so if I think about 2005 is 15 years since 1990. So my x is going to be 15 to find the value of how many students would be enrolled. So I need to find 114.4 times 15 minus 33.044. Okay, and we go with whole number of people. So if we calculate that out, we get 1,682 students. Or youth. No, they're not necessarily students. Okay, so that's it for the idea of linear regression. Watch our last video, and we'll be done with our notes for this section.